Okay, so to do the problems that you had last night, to do any light problems, you're going to use two formulas. Speed of light is wavelength times frequency, and energy is Planck's constant times frequency. So frequency is a big deal, okay? And hopefully you watched the video last night that talked about what frequency was. Wavelength is the length of the wave from here to here. We measure it in some kind of meter, okay? Light waves are so small that we use nanometers, 10 to the negative 9th meters, to measure them. But frequency, if you haven't gotten to that in physics yet, frequency would be if you stay in one spot. There's an eyeball, there's some eyelashes, okay? And if you just look at one spot and you set maybe a stopwatch for 1 second, and you count the number of waves that go by in a second. If you have a really long wavelength, not that many waves can go by your fixed point in a second. If you have really short waves, then more waves can go by in a second. Does that make sense? So, frequency is the number of waves per second. So, the number of waves, we don't put the waves, we just have a number. And so frequency is measured in per second, and that's where we get the unit, the hertz, which is abbreviated Hz. Okay? And I want to ask you guys a question based on what I said before. Is wavelength and frequency directly proportional or indirectly or inversely proportional?
Inversely?
Inversely. Because remember we said the short waves, small wavelength could have lots of waves go by. So small wavelength is high frequency, long waves are low frequency. Okay? What I need you to know though is that all waves travel at the same speed. Okay? It's just that because this is longer, less of them can go by in a second. But all of them are traveling at that same speed. What is that speed? What do we call the speed?
Nu?
We call it c. Anybody know what that stands for? Yeah, that's the speed of light. And light is a form of electromagnetic radiation. So we could actually call c the speed of electromagnetic radiation. The value that I like to use is 3 times 10 to the 8th meters per second. Get this a little neater. The book, I think the specific value, Jenny, you were saying what is 2.9979 times 10 to the 8th meters per second. But usually, even if you use that number, when you round to the right number of sig figs, you're going to get the same answer that you got this way. Okay? And notice, this will make it a non-calculator problem. Okay? If I give you 600 nanometers and want to know the frequency, you could work it out because of the 6 and the 3. Okay? So, that's how we work speed. This is what we use to work speed of light problems. So, for example, if I told you that we have some ultraviolet light, and let's say that the wavelength of some UV light is, let's just do 300 nanometers, okay? If we want to plug it into this formula, what do we first have to do to our wavelength? Convert to meters, because this is meters per second, not nanometers per second. So, you can do it the complicated way. There are 1 times 10 to the 9th nanometers in 1 meter, and you'll get 3 times 10 to the 7th meters. But I like to make it uncomplicated and just recognize that the prefix nano means 10 to the negative 9th. And so 300 nanometers is 300 times 10 to the negative 9th meters. Do you guys see that this is the same? Sorry. When you divide by an exponent, it becomes negative. Do you guys see how this is the same value?
Yes.
And if you're plugging it in your calculator or setting up a problem, this calculates just as well as this, and there's less room for error. Can you guys remember nano is 9?
Yes.
So I think there's less room for error if we convert it this way. So we plug that into our problem. Speed of light is wavelength times frequency. And I'm going to go ahead and rearrange this. We want to solve for frequency. So we're going to divide through by wavelength. So speed of light over wavelength is frequency. So we have 3 times 10 to the 8th meters per second over 300 times 10 to the negative 9th meters. I'm going to do this without a calculator. Okay? Don't get nervous. Okay? So, let's use review some of our math skills. All right. Isn't 3 going to go into both of these numbers? So won't this simplify to 1s? Okay, so now we're dealing with 1 over 100, right?
Yeah.
1 times 10 to the 8th over 100 times 10 to the negative 9th, right?
Yeah.
Okay, so what's 1 over 100?
0.01.
0.01? And there's a lot of different ways to approach the math of this. Times, am I still on the camera?
Yeah.
Guys, how do you divide exponents? You remember what you do?
Subtract it.
You do. So this is going to be 10 to the
17.
8 minus a negative 9. Right. So this will be 0.01 times 10 to the negative, or to the positive 17. Right?
Yeah.
And then if we want to move this over, right? Are we making this number bigger or smaller? Since we're making this number bigger, what do we have to do to the exponent?
Subtract.
We have to make it smaller, because we want our number here that we're just going to put in a different form to be equivalent to that number. So if we're making that smaller, then we have to make, yeah, we're making this smaller. No, we're making this bigger, so we have to make that smaller by 2. So that's our final answer. The units is 1 over a second. Or you could write